Okay, so in the previous video, we learned how to graph the square root of x function. Now we're going to learn how to graph the cube root function. So as you can see, I have my table here, and I have already selected some values that I know have a perfect cubic root. So let's start with the cube root of -8. When we take the cube root of -8, you get -2. So let's plot this point, -1, 2, 3, 4, 5, 6, 7, 8, and I am going to go 1 and 2 units. So here's my first point, -8, comma, -2. Now, what is the cube root of -1? Well, that means that what number times itself 3 times gives me -1, and that is -1. So let's plot that point. At -1, we're going to be at -1. How about the cube root of 0? Well, that's an easy one. 0 times 0 times 0 will give me 0. So this point is going to be right here at my origin. How about the cube root of 1? 1 times 1 times 1 gives me 1. So when x is 1, y will be also 1. And the cube root of 8 is going to be +2. So 1, 2, 3, 4, 5, 6, 7, 8, and up 1 and 2. Now, you might be tempted to say, oh, look, I have a straight line here. But remember that the cubic root function is the inverse of x to the third power. So while we might be tempted to say, oh, that's going to be a straight line, recall that our x to the third power looked like an s that was stretched out, and it was stretched out vertically, while our cube root function looks stretched out horizontally. So I'm going to make an attempt at connecting all these points, and let's see how well I do. I am connecting. Notice that it looks like a stretched S, and I need to put arrows on both ends because I do not have a restriction. Okay, so let's look at the domain. Are there any values of x that I cannot put inside of this radical sign? There aren't any. So that means that I can have all real numbers. And I'll just type all real numbers here. And for my range, since I do not have any restrictions on the x-axis, and you can see that I have a function graphed both on the negative side of my y values as well as on the positive side of my y values, that means that I can just copy that and type all real numbers for the range as well. Okay, now that we've graphed the parent function of the cube root of x, let's look at an example where we have translated the function. Now we have the cube root of x plus 2. Okay, so if you recall on how we translate functions, this is going to be a translation on the y-axis. So it's going to be moving up by 2 units. So my original parent function is just going to shift up 2 units. So again, because I know that I can take the cube root of -8, I selected to take the cube root of -8 and then add 2. Cube root of -8 is -2 plus 2 is equal to 0. So at -8 instead of being at -2, we're going to be at 0. So 1, 2, 3, 4, 5, 6, 7, 8 units to the left, and 0 on the y. How about the cube root of -1 plus 2? Well, that's going to be -1 plus 2 is equal to 1. So when x is equal to -1, I'm going to be up at 1. And when we substitute 0 for x, we're going to have 0 plus 2. So when x is 0, we are going to be at 2. And when x is equal to 1, we're going to be up at 3. So 1, 2, and 3. And when x is equal to 8, y is going to be equal to 4. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 2, 3, and 4. Okay, let me make an attempt at connecting these points. And you can see that it's going to look very much like the previous function. And if I can draw a little bit better, I just might be able to fit this point here. Okay, so as you can see, once again, we do not have any restrictions on the domain. So we have all real numbers, and we do not have any restrictions on the range. So we have all real numbers as well. I hope you found this videos helpful in terms of graphing the square root and the cube root function.